Today we will start a new chapter, that is the S block elements. So for this chapter you have to get a basic idea about the periodic table, which you already have, I think so, in class 10. So here we can say that the periodic table is classified into many parts like the S block, P block, D block, F block. So what are these blocks actually? You know that the elements have certain atomic number, they have certain electronic configurations, that the atoms are arranged because all the atoms do not enter the same shell, they have different shells. So when the last electron enters a certain shell, so that shell name is given to those blocks. Like for sodium, if you say sodium, what is the electronic number? It's 11, right? So and the configuration is, what is the configuration? 1s2, 2s2, 2p6 and 3s1, right? So the last electron, that is the number 1, the one electron that is left is entering the S subshell, right? So that shell is known as that block is known as the S block. So when we take out the electronic configuration of any element, we can draw which shell the last electron is entering, and with that we can say that this particular element is belong to that particular block. So here we are going to talk about the S block elements. Here I have already written the points that the last electron enters the S orbital. So those elements whose last electron enters the S orbital or the S shell is known as the S block elements. In S block element, again you have to know one thing, that is conceptual. It is the S subshell or the S shell can have 2 electrons at the most. Maximum 2 electrons they can have, but like if only 1 electron is left out, like for sodium, then that single electron will enter the S only, right? So when only 1 electron is left in the S, then it is known as the alkali metals. But if 2 electrons are there, like for magnesium, whose electronic number is 12 just after sodium, right? So at the last 2 electrons are left and they can enter, the last electrons can enter the S shell, right? S orbital. So here these are known as the alkaline earth metals. Now here we have talked about particularly about sodium and about magnesium, but what if like for we have talked about like 3s, 3s1, 3s2, right? There can be 4s1, 4s2, 5s1, 5s2. As we go down the group, the shells will increase, and every time the electrons will enter the shells. So for all those elements which entering the S orbital, whether it be 1s, whether it be 2s, 3s, 4s, like that it goes on. So all those block, all those, that part of the periodic table is called the S block elements. And for S block we have got alkali metals and alkaline earth metals. When we say alkali metals, because why we say alkali metal? Because the last electron is entering the S and there is only 1 electron, but maximum S can have 2 electrons, you know that. So S2 is also possible. So those are known as the alkaline earth metals, okay? Maximum 2 electrons S can have. What if like more than 2 electrons is there, like for aluminum, then that electron will go for the other orbitals, because maximum only 2 electrons S can have, but if electrons are left out, then they will go for the other blocks, other blocks, okay? Like 3s we have N naught, so it will enter the 3p. You can see here I have written for alkali metals. Why these are known as the alkali metals? Because those elements can form hydroxides, sodium hydroxide, right? So they can form hydroxides and they are basically basic in nature, they are alkaline earth metals. They can also form oxides and hydroxides, but they are obtained in earth crust, they are obtained naturally. So these are known as the alkaline earth metals. Now for S1, you see it's lithium, sodium, lithium, sodium, potassium, rubidium, cesium, and francium. Okay, for sodium, if it's 3s, then for potassium it will be 4s. For rubidium it will be 5s. The shells are always going on increasing. If we talk about S2 or the alkaline earth metals, we will get beryllium, magnesium, calcium, strontium, barium, and radium. Here, another thing you have to keep in mind is the period and the group. So when we talk about period, all the elements that is present along the period horizontally, what happened there? The shells do not increase in size. Okay, the cells do not increase in size, but the electrons go on entering. The electrons go on entering. Like for P, when we talk about p orbitals can have maximum 6 electrons, and as we go along the period, what happens? First of all, p1 is possible. Okay, for the next element one more electron will be added, no? So for that p2 will get. So at the last p6 will be there, and after p6 no more electrons will enter the p orbital. They have to move on to the next orbital, new orbital. But if we go down a group, then number of shells are increasing. A very sufficient example is here. If we talk about lithium, if we talk about sodium, potassium, if we compare all these elements, what happens? The shells are increasing, right? Because once we have talked about 3s, the next potassium will be what? 4s. So every time the new shells are being added here. This thing you have to keep in mind. Just have a look here. If it is for lithium, 1s2 2s1, because lithium electronic number is 3, so s maximum 2 electrons you give to 1s, because all the s can have maximum 2 electrons. After that you have to move on to the next orbital, right? So after we have given 2 electrons to 1s, how many electrons are left? Only 1. So that will enter the 2s. There is a sequence of these orbitals. Then for sodium, 1s2, 2s2. After that, after 2s, 2p will come. Okay, so this sequence you have to remember. It is 1s, 2s, 2p, after that 3s, then 3p will come. So like that it will go on, and you have to put the maximum number of electrons if it is there. For sodium, you see it's 1s2, 2s2, 2p6. Now how many electrons is completed? Only 10. But for sodium, you know there are 11 electrons. So that 11th electron, the last electron, will enter what? S orbital. Okay. Then for potassium also similar.